Welcome to Easy Gates Electrical Gate 22 Solutions. Next problem, another circuit problem, problem number 34 as per the master paper. It's a very interesting one, having a star and delta connected load as shown in figure. We have an ammeter. Okay, you need to assume the ammeter is a ammeter by default. Okay, then what is the reading of the ammeter? Okay, so you should assume ideal AC ammeter, and what will be the reading of this ammeter? So it is going to read the RMS current, okay, existing in the R phase. So the reading of the instrument, this is your IR. The meter reading is going to be RMS value of the current existing in the R phase. That's what it is going to read. Okay, simple. So what is given for us is a delta network in the outer and a star network in the inner. So leading to, you can exploit a simple star to delta or delta to star transformation. So it's up to you whether you want to convert the outer delta into star or inner star into delta. Okay, and think once and then start applying. Suppose if I convert the inner star into delta, then the delta equivalents of the inner star will be in parallel with the outer delta. That is one way. But in that case, your delta equivalents, okay, the final net equivalent of the delta you're going to form are going to sense your line voltages. Okay, so then IR is the current existing in the R phase. So then you have to go for two currents in the delta connected, and then you have to go for a complex addition. Then you have to get your IR. That is how you need to imagine the route. That is the first way. Suppose converting your inner star into a delta. Instead, if we convert your outer delta into another star, how it will look like means the inner star is already having a point. Okay, and outer delta converted into star, the two star points, okay, are not identical. That means you can't simply convert the outer delta into star and then superimpose that star on the existing inner star. And remember that the two star points are unique. Okay, but still they are identical in what aspects means the two loads are the inner star, it is already balanced. Then the outer delta converted to star also going to be in balance. If that is the case, the star point of inner star and the outer delta converted to star will have same potential. That means the same neutral point. That means both will be 0 volts. So you can superimpose them. But physically, you can't connect the two star points. Okay, so let me go for the second case. That is, I'm going to convert the outer delta into star. So this is Z1, this is Z1, this is Z1. If I convert a delta with identical elements into star, the net impedance is going to become 1/3 of the existing one. So it is going to be Z1. So therefore, it is going to become Z1/3. So that is going to be a star. So then I'm going to play with the two stars. We'll see. Okay, this is one route. Okay, you can think about another route, converting inner star into delta. Let me go by converting outer delta into star, and the star is going to have the another star we are going to make is going to have Z1/3. So if you do this, then the resultant will look like this image. Okay, so it will look like this. Okay, so before that, let me get into the problem. What is given? Given Z1 and line voltage is given 100 into √3. So VL is given 100 into √3. Then the phase voltage, individual phase voltage will be equal to V phase will be equal to 100 by √3. 100 √3 by √3. So it's going to be 100 volts. So each phase will have RMS of 100 volts. That is your VRN, VRN, VYN, VBN, all will have magnitude 100 volts. Okay, they will have their respective phase angles. So we'll talk about them when necessary. Okay. Yes, now the impedance Z1 is given as 18 plus J4. Therefore, Z1/3 is going to become 18 plus J24/3. That is going to become 6 plus J8 ohms. Z1/3 is going to become 6 plus J8. And interestingly, Z2 is also given 6 plus J8. Okay, so therefore the equivalent is going to be something like this. So since, okay, I don't want to lose that important information, the two stars are going to be at unique points. So I don't want to make them parallel. Let me go like this. This is 6 plus J8. This is also going to be 6 plus J8. So this is the R phase. Let me treat this as a neutral, and this is the R phase. This is also the neutral. Okay, it looks like the two stars in parallel, but still, let me go by this phase. So what is the voltage across this? It is going to be VRN. So what is the voltage across this? This also VRN. That means effectively the two impedances are in parallel, but still I'll go for the separate currents. This is the reading. That's a meter current. I'm looking for RMS meter current. Okay. So what is the current in this? It is going to be, so VRN, we know VRN is equal to 100 is the phase voltage at an angle 0 degree volts. So this is 6 plus J8. So let me take this as VRN divided by let me call this as a Z, and this is also going to be Z. So VRN by Z. And this is also going to be the current VRN by Z. So therefore this current, the current through the instrument IR will be equal to 2 times VRN divided by 6 plus J8, that is Z. Okay, that's your IR. So we'll go for modulus of this, that's a meter reading. So 2 times it is 100 at an angle 0, the whole divided by your AZ, that is going to be 6 plus J8 ohms. Okay. So we'll go for the magnitude. Okay, that will be the resultant. Okay, what is that? 2 times 100, that's a voltage RMS, and divided by root of 6 square plus 8 square. Okay, that is going to be 2 into 100 divided by root of 6 square plus 8 square will be 36 plus 64, that is root of 100. Root of 100 is going to be 10. Therefore, the result is going to be 200 by 10, that is going to be 20 amps. As per the plan, that's modulus of IR. So that will be the reading of your usually a moving iron instrument. That's a AC instrument for this 50 H power supply. So that is going to read a value of 20 amps. That's a RMS value of your R phase current. Okay. So that's another interesting problem happened in electrical gate paper, K22 paper. That's easy once you convert outer delta also into a star network. Okay, and hope you understood the content delivered. Do subscribe the channel and look for further updates. Thank you.